we're going to get started and talk about coaxial cable splitters. Okay, they come in a variety of types. There's a two-way, three-way, and so forth. Okay, so what happens when you split the decibels, the signal coming in from a coaxial cable with a splitter? It's going to divide the signal based on the number of splits you're doing, the number of outputs. Okay, and that's going to reduce the level of signal coming in, or decibels. Okay, so there's some questions on the Florida electrical exam that relates to these splitters, maybe 3 to 5 questions that you're going to have to know how to calculate. It's quite simple, and we're going to go through it, and I will take you through a few of those. They give you a little legend there that tells you, and I think it's 3.5 for a two-way splitter, which is the standard 3.5, 4. 6.5 for a three-way splitter, and then minus 8 decibel loss for a four-way splitter, and then 11 for a 8-way splitter. Okay, so you come in here with your cable, and then it splits the signal, and there's some signal loss there, attenuation. Okay, and let's take a look at this example. And this is what you're actually going to have. You're going to have a picture on your computer screen that's going to look something like this. And they're going to ask you a question on TV 4, what's your decibel level going to be? Okay, so let's take a look at a few of these, and we'll start from there. Okay, dB loss at TV 4. All right, let's look at TV 4. TV 4 is down here. It goes through a two-way splitter and a four-way splitter. Okay, before it gets to TV 4. Now, the signal input is already at a negative decibel level, so it's coming in at a negative 16. Now, they may or may not give you the dB input level. It could be a positive, could be a negative. Sometimes they don't show you that level, and you're going to have to assume maybe it's 0, and then you would add up whatever splitters there are there as to the negative factors. Okay, because when you split down the signal, you're making it less signal strength. Okay, not really voltage, it's signal strength. So or you can consider it like sound level if you want. Really not exactly sound level, but it's signal strength. But in any case, so here we got a two-way splitter and we got a four-way splitter. We're already at minus 16, so we take minus 16 and then we add the two-way, which is 3.5. So minus 16 plus 3.5 plus the four-way splitter, which is minus 8, and you come up with a total of what? Minus 27.5. Okay, let's look at the next one. TV5. TV5's over here. And we just traced TV5 back. We got a two-way splitter and a two-way splitter, and we're adding in the minus 16. So two ways is 3.5 times 2 is 7, minus 7 now, plus minus 16, and you come up with 23. Okay, so you grab a calculator and kind of do this along. It's quite simple, but if you don't understand it, this is the time to learn it, right? TV 12, it's way over there. Let's trace back TV 12, and it goes to an 8-way splitter, back to a 3-way, to a 2-way, and a 2-way. So we've got to add the 8-way splitter, which is minus 11, plus a 3-way, which is minus 6.5, plus another 2-way, which is minus 3.5, and another two-way minus 3.5, and what do you come up with? Very low signal. Minus 40.4. I'm not even sure that would even work. But in any case, let's do another one. We already did that. I'm not sure why I'm showing you that again. Yeah, I think we already... Oh, okay. Well, we changed something here, I see. I see what we did. Okay, before we had a minus 16, right? Now look at it now. Now it's different. It's a plus 16 decibels. Okay, so it's different because that's a positive number, and you're going to be what? Subtracting the negative number from it because the splitters are going to reduce it, so that's a negative. So TV4 then would be here. So I got 16 minus the 4-way, which is minus 8, and then also minus a 2-way, which is what? Minus 3.5, right? Come up with what? A positive 4.5. Plus 16 minus comes up with positive 4.5. Let's take the next one, TV5. TV5, I've got a what? A 2-way and a 2-way. So that's two 2-ways. So that's minus 7 decibels. So you have 16 dB coming in, and you minus 7 decibels from it, and you get a positive 9. Right? One more here. dB loss at TV12 equals what? All the way at the end, TV12, and again, we got quite a few splitters here. An 8-way, which is minus 11. A 3-way, which is minus 6.5. A 2-way, which is minus 3.5. And another 2-way, minus 3.5. Add all those minuses together, you still have a negative number. You subtract the negative number from the 16 decibels, and you come up with a minus 8.5. Okay? Now, what do we have on this representation here, this block diagram? You have no input at all here, so you're to assume the level is 0. All right? Just keep it at 0, and I believe this is what the way they're going to present it to you, with some dB coming in and with no dB there. So basically, quite simply, the first question is TV1. Well, TV1's down here. And what do we have on top of that? We go through a 4-way, go through a 3-way, go through a 2-way. So we've got to add a 4-way, which is minus 8. Then a 3-way, which is minus 6.5. And then a 2-way, which is minus 3.5. Add all those up, and you get what? Right, minus 18. Oops. Well, I've pretty much given you the answers for all the other ones there for some reason. Not sure why I did that. I guess I wanted you to do these. Okay. Might want to go back and do all those, and then you can stop it and go back to that if you like. All right, we got some more of these here. Here's another representation. TV1. TV1's down here. A 4-way, a 4-way, and a 3-way. Okay. TV7. Where's TV7? Way up there. TV7. Follow it back. It's got a 4-way splitter. And then it goes back to the source through a 3-way splitter. So you got a 4-way plus a 3-way. TV8. I'll let you do that one without me saying anything. You can follow my cursor. And here are your answers. All right. You learned that simple steps on how to calculate decibel drop on coaxial splitters, and you'll have 3 to 6 questions correct.